All right, hello there. So we're going to finish section 12.5 here. And so the last part is about planes. So how to do the equation of a plane. Now, one thing that you have to notice about a plane, and I'll try to show you in class next time, but a plane, you can't give me a line on a plane to tell me the direction of a plane. Because lines, like if you have a plane, and you have a line on here, and then another line, and any line on there. Multiple lines can be on a plane, but only one, or multiple vectors can be on a plane, but only one vector is ever perpendicular to a plane. So you see that in this picture down here. Right? There could be any number of things on this plane, any which direction, but only one thing ever sits at a 90-degree angle to a plane, and that's its normal vector. So you have to find the normal vector for the plane using two vectors on the plane. And you know that a normal vector means a perpendicular vector, so you do know how to find a vector perpendicular to two other vectors. Hopefully you know that's the cross product. All right, so here we go. All right, so the equation of a plane in space is obtained from a point in the plane and a vector normal to it. So normal, basically perpendicular. All right, so what I just explained there about planes having infinite number of lines in their same direction, but there's only one thing perpendicular to it. This normal vector is going to be the cross product of two vectors on the plane. So we will be using that plus another point on the plane, and that's how we're going to get our equation. So here we have a plane contains a certain point, and it has a normal vector to it. All right, and so then the equation of our plane can be written in a few different ways. I think we'll just go ahead and do one, because that's all that we ever usually see it, or actually two. So you can write A, x minus x1 plus b, y minus y1 plus c, and then z minus z1 equals 0. Now, this is going to be kind of like the basic way to write it, or we'll call it the babyish way to write it. Anyway, so we're not going to write it like this. We are going to write it here. ax plus by plus cz equals d. And so the second one is just a version of the first one. I want you to notice that if I were to multiply, distribute out, distribute, that's where I would get this piece from right there. And then something else to notice. Do you notice that when you multiply a times x, b times x1, c times z1, those are all just going to be numbers because you're given those numbers up here. And what you're effectively doing is you are multiplying them, adding them up because they'll all be negative per se, and then putting them on the other side. So really you're just doing the dot product. All right, so this piece right here, just a little quick way to do it. This is just the dot product. Remember, because it's a D if you want to. This is the dot product of the point and the normal vector. And I'll try and show you on the first example what I'm talking about. You don't want to sit here and do this formula all the time because it takes so long. If you just go boom, 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 put A, B, C in front of X, Y, Z, and then do the dot product, you'll have your answer a lot faster. All right, so here we go. So I want to find the general equation of a plane containing these points. So first of all, I need two vectors. I can't use all these points. I need vectors. So we're going to call this one A, B, and C. So I'm going to make a vector from A to B. That'll be on that plane. All right, so I'm going to subtract b and a. So 0 minus 2 is negative 2. Then 4 minus 1 is 3. Then 1 minus 1 is 0. Then I'm going to do another vector from, let's say, b to c. It doesn't really matter which ones you do. All right, so negative 2 minus, let me see, b, negative 2. Then 1 minus 4, negative 3. Then 4 minus 1, 3. Okay, so there's my two vectors. And so now I have to do the cross product of these two things because I need to find a third vector that's perpendicular to these two. All right, and so I'm not sure if I've matched the ones in the picture over there. I might not have, but whatever, we'll just go with this. So ijk, and then I need -2, 3, 0, -2, -3, 3. I need to do their cross product. All right, so why don't you practice a little bit in that puzzle and do that cross product for me. All right, so that cross product, let's see, the I part is going to be 9 minus nothing, so 9i. The j part is going to be -6 minus nothing, but maybe remember I'm going to do the opposite, so it'll be positive 6j. And the k part's going to be 6 plus 6, so 12. All right, so plus 12 ijk. All right. All right, now I know that reduces by 3, but you can't do that yet. So we are going to take those numbers. That is my a, which is 9, and do x minus. Now I can use any point that I want. So I'm going to use 2, 1, 1. So 2 plus b, so 6, and then y minus 1. I'm going to use this point here. And then plus 12, and then z minus, let's say, 1. All right, equals 0. All right, so at this point, you could divide everything by 3. I just didn't want you to do that yet, just in case we're going to do something else in a second. But you could divide everything by 3 to make it a little easier. But let's just multiply it out like we see here. So I have 9x. I'm going to take my 6y and the 12z. So I want you to notice, we're all like high up in math here. This is going to be a -18. This is going to be a -6. This is going to be a -12. So 18, 6, and 12, that is 36. Okay, so this can be -36, and you can put it on this side if you want to, but eventually I want it on the other side, so I'm going to say equals 36. Okay, so see with me that that is just the dot product of this normal vector and my 2, 1, 1. If I did that, I would get 18, 6, and 12, and that's 36. And so that's why I wanted you to see the quick and easy way to do this, and it will save us a lot of time. So anyway, you can leave it like this. I mean, this is technically my answer, but you can also reduce it down. Divide everything divides by 3, even the 36. So I could say 3x plus 2y plus 4z equals 12. So you could also say that. All right, so the next one. Find the equation of a plane that contains this line and is parallel to this plane. So parallel to this plane, so you're telling me that you're going the same direction as this plane. So that means you have the same normal vector of this as this plane. So there's your normal vector right there. My normal vector is 2, 4, and 8. So you could use that 2, 4, 8, or you could use 1, 2, 4, like, reduce it all by 2, whatever you want to do. But I have half of what I need. I have a normal vector, and now I need a point. So that's where I'm going to use the line given to me. It says the equation of the plane that contains this line. So this line is on my plane. So what I'm going to do is I'm going to snag away the coordinate, and that one's a 0. I'm going to snag away the coordinate that this line goes through, the point that this line goes through, 3, 0, 8. So I'm going to use these two pieces of information and go ahead and get my equation. So remember, this normal vector, I'm just going to pop that in front of x, y, z. So 2x plus 4y plus 8z equals, and then all I will be doing for the other side is dotting this with this. So I'll get 6, 0, and 64. So that'll be 70. So equals 70. And then they're all reducible by 2. So x plus 2y plus 4z equals 35. And there is the equation of my plane. Okay? All right. So moving right along here. When are two planes parallel and when are they perpendicular? So basically two planes are parallel when they're normal vectors are scalar multiples. Or they have the same normal vector, okay? When are two planes perpendicular? So I just use my good old perpendicular rule. I would say that when they're normal vectors, so normal vector 1 is perpendicular to normal vector 2, so that would imply that normal vector 1 dot with normal vector 2 equals, what is it? You got it? 0, right? All right, if planes are not normal, how do they intersect? So let's take a second here and look at two planes. Let me see if I can get my fancy, my 3D calculator here. And let's just draw a couple planes. Like how about 3x plus 2y All right, so there's a plane, let me see, minus 3z. Oh, that didn't look good. Let's say equals 5. Let's see, there it is. All right, so that's fine. All right, so remember the x-axis is my, what's it called? My positive, the x-axis is my red one. Okay, so there's a plane right there. And then let's do another one, like how about z equals 2? I'm just going to keep it simple this time. All right, so look at that intersection right there. When two planes intersect, they intersect at a what? So they don't intersect at a point, you guessed it, they intersect at a line. And so I have to have an equation of a line for the intersection right there. All right, so here we go back to where we were. So if planes are not parallel, how do they intersect? They intersect in a line. Okay, and so let's ask this question here. Are these two planes parallel? So let's take a look. So first of all, you have to get everything over on one side. So this normal vector here is -8, -6, and 2. This one here, I got to bring everything over. So I'll just say 4x plus 3y minus z equals 0, everything together. And this one's 4, 3, and -1. So look at those two things. Yeah, I think if I multiply this guy by -2 in my head, I get -8, -6, and 2. So they are parallel. So yes. Okay, so these two down below are obviously not parallel in the next example. So find the intersection of the planes given by this. All right, so here's a process we're going to follow. So we have a system of two equations and we have three variables. So whenever this happens to you and whenever you want to see that when two planes cross each other, you have to get rid of one of the letters. And so or one of the variables. And so I'm going to do some addition method process and get rid of, I don't know, the z's. Okay, so what I'm going to do is I'm going to subtract these two lines. It's kind of like in Algebra 1 when you solve a system of equations, right? So I'm going to subtract these two lines, and that's going to replace my second line. So when I subtract these, my first equation is going to stay the same, x plus 2y minus z equals 8. When I subtract them, I get x minus 2x, so that's -x. Then I get 2y minus a -y, so it turns into plus, so plus 3y. And then, like I wanted, my -z plus z, this goes away. And then I get 8 minus 5 is 3. So at this point, what you're going to do to get the equation of your line is this. You're going to take either one of these two letters right here. I know this is kind of weird. We'll practice it in class and stuff like that also. But you're going to take one of these two letters in this equation and you're going to set it equal to a variable, t or a or some just constant or some variable right there. All right, so I'm going to do this. I'm going to say, let's let y equal to t. All right, so that means that I have -x plus 3t equals 3. And so this is one of my answers. This is one of my parametric equations for my line. So I'm going to start those over here. So I have y equals t. It's always one of the two letters where I have, for the equation that I have two things left in. Like right here, I could have used x equals t, but I chose y equals t because it looks simpler. All right, and so now let's solve this for x. So I'm going to move this x over to the other side. Then I have 3t minus 3. So there's the next parametric equation, 3t minus 3. And then for the third one, I can pick any of these two original problems. I think I'll just use the top one here, and I'll plug these things back into it. So I have x, so I put 3t minus 3 plus 2. Now y is now t minus z equals 8. Well, let's move that z over and bring the 8 back. So I have 3t, so I have 5t. I have a minus 3 and a minus 8 coming over, so minus 11. So there's my third equation, 5t minus 11. And there is my parametric equation of the line of intersection of these two planes. All right, so we'll practice that, but here we go. All right, so the point of intersection of a line and a plane. So sometimes, or not sometimes, but you know, when you have a plane and you have a line, you know, you can picture that. Like if I have a plane right here and then I have a line, you know, coming up through it, you know, and this goes underneath that right there. So there's a point of intersection. So they intersect at a point. Okay, or I mean, unless they're parallel, but that doesn't, otherwise you won't get them to intersect then. All right, so I want to find the point of intersection of this line and this plane down here. So my line, remember, parametric form is always the best thing. So let me put this over 1 right here. So I can tell the parametric form of this thing. Oops, why did I start with z? I meant to start with x. So x equals, remember that'll be 3t plus 2, because these are all equal to t. Y equals, that'll be t plus 3. And then z equals 3t plus 7. All right, so think about it. A line and a plane are going to meet when their x, y, and z match at a certain point. So basically what I have is that x has to equal this, so I'm going to put x right there. Y has to equal that, so I'm going to put y right there. And z has to equal this, so I'm going to put that right there. And when I put that in for x, y, and z, I'm going to have an equation with t, and then I'm going to figure out t, and I'm going to plug it back into my 3 parts to find my point. All right, so here we go. So 2, and then I have 3t plus 2, plus 3, and then t plus 3. And then, let's see, minus 4, z is 3t plus 7. And then I have plus 21 equals 0. So why don't you solve that and see if we get the same answer. All right, so when I multiplied this all out and simplified it down, I ended up with a negative 3t plus 6 equals 0. And so t was 2. All right, so let's see, make sure I'm getting this good. Yep, all right, so t is 2, so let's plug that back in here. So that means that x would be 6 plus 2, so 8. Y would be 2 plus 3, so 5. And z would be 6 plus 7, so 13. And there is my point of intersection. That's where they intersect. Alrighty, the angle between 2 planes. So this is just like the angle between 2 vectors, of course, if they're not parallel. So remember that formula you had before. You had cosine theta equals u dot v over magnitude of u and magnitude of v. Well, it's the same thing except we're using normal vectors. So you do cosine theta equals normal vector 1 dot normal vector 2 over the magnitude of the normal vector 1 and magnitude of normal vector 2. All right, so we're going to do that down here. So down here I have cosine theta equals, I do the dot product of my 1, negative 2, 1 from the first plane, and 2, 3, negative 2 from the second one. Then on the bottom I do the magnitude of each one. So this guy, its magnitude would be 1 plus 4 plus 1, so radical 6. And this guy here, magnitude would be 4 plus 9 plus 4, so 8 plus 9 is 17. All right, so I do that dot product up top, and you get negative 6, and then the bottom multiplies the radical 102. So grab your calculator, you get your angle is 126.4. Now realize, when 2 things cross, I know those aren't planes or lines, but we just got this big one. You could also be asked for this piece. All you gotta do is subtract from 180. So if I did that here, I could also say that the angle is 53.6. So a question might say, what's the acute angle between the planes, or what's the obtuse angle between the planes? So just realize that you can just fix them real quick. All right, so let's see. Determine if these planes are parallel, perpendicular, or neither. So first of all, let's get this in the correct format here. I got negative 6x plus 9y plus 3z equals negative 2. All right. If they're going to be perpendicular, that means a dot product of their normal vectors would be 0. So let's check it out. 2 times negative 6 would be negative 12. Negative 3 times 9 would be negative 27. And finally, negative 1 times 3 would be negative 3. That's not going to come out to 0. All right, let's check out the normal vectors. I got 2, negative 3, negative 1. And then I have negative 6, 9, and 3. All right. I think I see a multiplication by negative 3, right? So this times negative 3 equals that. So parallel. All right. All right. One last little thing we have to do is if you want to know the distance from a point to a plane. So it's going to be the shortest distance. So it's going to be the perpendicular distance. So if you have like a plane sitting here and you have some point in space, it's going to be the distance perpendicular. It's always the shortest, perpendicular to the plane. All right. You don't want to sit there and go, oh, let me go all the way over here, or let's go over here, or right here. Those aren't going to be the shortest. The shortest is going to be the perpendicular distance. Okay. All right. So we have to just evaluate this formula here. So I have a point. I have my plane. My point is going to be the x1, y1, and z1 in my formula. Here is my ABC. C is just 1 right there. And my D value needs to come over to the other side. That's the only thing you have to remember here when you do this problem. D has to be together. So you have to have like AX plus BY plus CZ. That D has to be brought over to the other side. So you have to have it equal to 0 there. And it might not be positive, but that's how you have to have it. All right, so here's my distance. So up top, I have these bars here. I have A times x1, so I have 4 times 3. Then I have plus, let's see, B, so I have -6 times -2, plus C, let's see, C is 1 times 7. And then D is coming over as a negative, so I'm going to put -5. And on the bottom, I do basically the magnitude of the normal vector, so that would produce 16 plus 36 plus 1. Okay, all right, so here's my distance coming to me. So let's see, the top part's going to be 12 plus 18 plus 7 minus 5, so that gets me a 26. So those bars up there are in fact absolute value bars, so 26 is already positive. On the bottom, I get the square root of 53. So that is my distance. So if you want to put that in the calculator, see what it is, but don't really care, so units. Okay, so that's the distance formula between a point and a plane. And that is it. Bye-bye.